Hello everyone, I cordially welcome you all to another video from the Python tutorial series, and in this video we are going to learn what are the 4 pillars of object-oriented programming. Before we start, I have a small request. We have been recently observing that many of our lovely audience have not subscribed to our channel yet. So I will request you all to please subscribe our channel, as that will motivate us to bring more videos in future. So I hope by now you have already subscribed to our channel. So without any delay, let's get started. The first pillar of object-oriented programming is inheritance. In case of real-world objects, every element is specialized within its general group of elements. For example, if we have a general class animal, it can have 2 specialized classes like wild and domestic. Under domestic, also we may have multiple other specialized class. Thus, wild is a specialized subclass of the parent animal class, and the properties of wild class share some properties with its parent class, but it also has some unique properties which makes it unique within its parent class. This is what inheritance is. So if I dilute this information a bit, as you know from the meaning of this word inheritance, child classes can inherit properties and methods from its parent class. Okay, so child classes should be specialized classes within the parent class, and child classes should contain all the member methods and variables present within the parent class. But the child class should not be restricted to that. Child classes may have their own methods and member variables that will make it a specialized class. Okay? If you don't understand this by the theory, please hold on with us now. Very soon we will learn using examples. Okay? Let's go to the next slide. The next pillar of object-oriented programming is encapsulation. In Python, we can protect the member variables of a class from being accessed by any program outside our class using the principle of encapsulation. Encapsulation means binding up of code and data together under one wrapper, which we already know as class, and provide proper access to change or modify the data of the class. We hide the variables by providing one underscore as prefix to the name of the variable. Okay, so basically, as I have already told, class is one of the fundamental concepts of object-oriented programming. Okay, and every class wraps the member methods, the member variables using it. So any member variable should not be accessed directly. It is always a good practice to use member methods to update or access those variables. Okay, so don't worry as of now. Once the 4 pillars are done, we will learn an example for each one of them. Okay, let's go to the next slide. Polymorphism. The word polymorphism has been derived from Greek literature, meaning having many forms. It generally emphasized on the fact of common interface for general set of activities. Okay, so basically using this pillar of object-oriented programming, we can define same methods, but they will behave differently based on certain situations. And if you don't understand this as of now, don't worry. Let's first discuss about the 4 pillars of object-oriented programming. Then we are going to see an example for each one of them. Okay, let's go to the next slide. The last pillar of object-oriented programming is abstraction. The concept of abstraction in object-oriented programming is mainly utilized to create a blueprint of a class. Like we just defined what member method should be present in the class and not the way how the class implements them. The abstract class just defines what method should be present in the classes which inherits it and not what methods does. The activity of method is left on the subclass to decide which inherits the abstract class. Okay, so what is the meaning of this statement? Basically, abstract classes are those classes which defines what member methods and member variables will be present, but it does not state how those methods going to behave. The behavior, or you can say the implementation, is left on the subclass to be dictated. Okay. By default, Python does not provide abstraction. There is a module named ABC, Abstract Base Class, which helps us to realize the concept of abstraction in Python. So there is one benefit if you are having some knowledge of Java programming language, that is, these 4 pillars of object-oriented programming is valid in Java as well. And in Java, you don't need any other third-party module to realize this abstraction concept. But in Python, we use ABC, Abstract Base Class, to realize the concept of abstraction. Okay. We have done enough of theory as of now, so let's go to VS Code and see an example for each one of them. Welcome to VS Code. Here we are going to see how we implement the first pillar of object-oriented programming, that is inheritance. So first of all, we have defined a class animal. Within this class, we have a member method sounds, which prints this animal makes some sound. Okay. Thereafter, we defined a child class or a subclass wild, which inherits the animal class. So this is how we define inheritance. The subclass followed by a pair of parentheses, and within the pair of parentheses we write the base class. In the child class we define as pet, which prints this animal can't be pet, because as we already know, wild animals cannot be pet. Okay. We have another child class domestic, which inherits from animal class, and here we have the same as pet method, but here we print this animal can be pet. Okay. So when we inherit animal class in both our wild and domestic subclasses, it doesn't mean that both these subclasses will only contain one method, that is as pet. This sounds method, which is defined by the parent class, will be present in both the subclasses. Okay. Thereafter, we define our first wild animal, that is tiger. So we create an instance of the wild class and we assign it in a variable called tiger. So when we say tiger.sounds, we should see this animal makes some sound. Okay. And when we say tiger.aspet, then we should see this animal can't be pet. And we see this statement because this tiger is an instance of wild class. Okay. Let's run the code and see if it is working. So I will write Python 22.py. So in the first two lines you can see this animal makes some sound because we call this sounds method. In the next line we see this animal can't be pet because we are calling an instance of the wild subclass. Okay. Ignore these lines as of now because these are coming due to the other examples which I have in this file. Okay. Let's go to the next example. Here we will learn what is encapsulation. Okay. So as I have said in the presentation, encapsulation means wrapping up of code, member methods and variables by classes. So first of all, we define a class animal. Here I have defined my own constructor. Okay. So as I have said, by default, even if you don't define any constructor, there is a default constructor which already exists. But in case you want to override the default constructor, you can do it. So here we define def, thereafter underscore init underscore. This double underscore defines that this method will not be called by any Python program. This will be called by the interpreter to create an instance of this animal class. Okay. Within this constructor, we pass a value, that is species, and we assign this species to one of the member variables of this animal class, and that member variable will be underscore species. So this underscore species define that this is a member variable, and it is a good practice to define an underscore before any member variable in a class in Python. So we assign this species value to the underscore species, which is the member variable of this animal class, and we have a sounds method which prints this animal makes some sound. Okay. Thereafter we create an instance of this animal class and we pass tiger. So when we pass tiger, this tiger is received in this species parameter and that gets assigned to the species member variable. And when we print tiger.underscore species, this prints tiger in the terminal. Okay. But here always remember, though I am directly accessing the member variable using this dot access specifier, but it is not a good practice. The best way is you define another method which will return the species member variable. Okay. And when you want to update this species, again you will have another method which will update the value. Never ever directly update any member variable within a class. Let's run this code and see if it is working. So I will write Python 22.py, and as you can see, we see tiger because we print tiger.underscore species. So as we are passing tiger over here, that gets assigned to the underscore species member variable. Okay. Let's go to the next example. In the next example, we are going to learn about polymorphism. So polymorphism means having many forms. Here I have defined a class dog which have a membered method make sound and it prints dog's bark. I have another class tiger which has a make sound membered method which prints tiger's growl. Thereafter we have a common interface which accepts an animal and it calls the make sound method within it. Okay. Thereafter we are creating instance of the dog class and assigning it to my dog, and we are creating another instance of tiger class and assigning it to my tiger. Thereafter we are passing check make sound my dog. That is, we are calling this check make sound method and we are passing our dog instance. And in the next line we are calling this method but passing our tiger instance. So when this dog instance is received in the animal, the make sound of this my dog will be called. That is, we will see dog's bark in the terminal. And when we are passing this my tiger, so my tiger is an instance of the tiger class and its make sounds print tiger's growl. So when we pass this object to the animal, it will call animal.makeSound. That is, my tiger.makeSound will be called, and then we will see tiger's growl in the terminal. Okay. Let's run the code and see what we are telling is correct or not. So as you can see, in the first line we see dog's bark and in the next line we see tiger's growl. Okay. Let's go to the last example for today's video. In this example, we are going to learn about the last pillar of the object-oriented programming, that is abstraction. So I have already told that abstraction cannot be directly implemented in Python. We need to import capital ABC from small abc, and here small abc means abstract base class. Okay, we define a class book which inherits from the abstract base class. We have a method book name and we write pass because we don't define the method body. This is the abstract method. Okay, now we create another subclass Python which inherits this book class, and then it defines this method. That is, here we have book name and this print, this is the Python programming book. We have another class Java which inherits this book class, and in its book name we print this is a Java programming book. The main concept of abstraction in Python is for any member methods, no body will be defined. The classes or the subclasses which inherits the abstract class should define a method body for the abstract methods. So as you can see here, in this book class, this book name is an abstract method because it doesn't have any body. But in case of Python and Java, which inherits this book class, defines a body for this book name method. Okay. Finally, we create an instance of this Java class and we assign it to myBook variable. And finally, we call myBook.bookName. So as myBook is an instance of Java and we are calling book name, that is, it will print this is a Java programming book in the terminal. Let's run the code and see if it is working or not. So if I run this code, you will see this is a Java programming book. So our code is working. So here one by one we have learned about the 4 pillars of object-oriented programming with an example for each one of them. In case you have any doubt, I will post the link of our blog in the description section below. You can go and check it out. Okay. Let's go back to our presentation. I hope you found this video really informative. In case you like this video, feel free to hit the like button and subscribe to our channel, as that will highly motivate us to bring more videos in future. For any queries, doubts, suggestions or feedbacks, feel free to post them in the comment section. We are going to reply. So thank you for now. See you in the next video. Bye.